Good morning. Good morning.
Good morning.
All right. Hope everybody's doing well. Everybody's doing all right. All right. Got one more person trying to get in here, so let's give them a chance. All right. So before we get rolling, anybody have any questions, concerns, comments? Everybody good?
Good. Thank you.
Okay, cool. All right. So let's see. We left off 17.5. So we should be looking at 18, excuse me, 1 today. All right, just making sure my section. So we'll do 18.1 and 18.2. And okay, there go 18.6, just making sure. All right. So let's you can go ahead and write down this first title, 18.1 quadratic equations. Want to solve by completing the square. Then I'm gonna switch to another set of notes. So that red statement is, for me and my reminder. As a matter of fact, yeah, you can write down both. Those are both of our titles, both of those in the same section. So 18.1 is quadratic equations by completing the square. 18.2 is quadratic formula. So when I go to this next set of notes, we're going to do both of those and we'll just flow into both of them. All right, we good. All right, so let's look at 1.5 here. One second. All right, so, of course, you don't have to write that 3, but this is where we start completing the square. So these are our steps. So if we want to solve the equation ax squared plus bx plus c equal to 0, first thing we'll do is going to, if a is not equal to 1, a is the number that's sitting in front of x squared. If a is not equal to 1, then we'll divide both sides by a. In other words, you're going to divide each term by a. Step 2, we're going to isolate c. That's the number that's not attached to x at all. We're going to isolate that. In other words, put it to one side by itself. That's what I got over here in this purple. Step 3, we're going to take half of b and then square it. Then we'll add it to both sides of the equation. Need a chance to write that before I scroll up. All right, scrolling up some. So 4, we're going to factor the perfect square trinomial, simplify the other side. Five, we're going to solve using square root property. So we'll talk about that, when we actually do it, if you don't remember what the square root property is. So that's fine. Don't worry about it. We'll talk about it. All right. Then check is always the last step. Whether you do it or not. In this case, if you do everything correctly, you still get it right. You should have the right answer, but always can plug it back into your equation and check. All right, we're good to go. Try out these steps. So we try going step by step and try to line up, our steps with what was said in wording. Anybody still holding on to the black? All right, so the first one, excuse me, we have x squared minus 6x plus 4 equal to 0. First step says if a is not equal to 1. So a is always what's in front of x squared, so it is equal to 1, so there's nothing to do for step 1 because a is equal to 1. Step 2, you want to isolate the constant, so I subtract 4 from both sides. So now I have x squared minus 6x equal to negative 4. So whatever number is not attached to a variable at all, you take it to the other side. And so we did that by subtracting 4 from both sides. All right. So now step 3 is to take half of your b term and then square it. So our b term is the number that's sitting, that's the number that's attached to just x. So that would be negative 6. So that's b. So right here, took half of that, which is negative 3, excuse me. And then I squared it, which gives me 9. So you will always take half of that term that's sitting in front of x, and then you will square it. And then the next part of step 3 is to add that 9 to both sides of your equation. So that's what we have here, x squared minus 6x plus 9. Some stuff in this table. So x squared minus 6x plus 9 equal to negative 4 plus 9. All right, any problem with steps 1 through 3? All right, scrolling up. So now we can factor that trinomial that's on the left and then simplify what's on the right. So on the right, negative 4 plus 9 is 5. On the left, though, we have x minus 3 squared. That's what this factors out to be. Now, if your factoring is not as strong as you like it to be, that's fine. Whatever half your b term is, it is what goes here. So notice half of negative 6 is negative 3, and that's why you have x minus 3. So this right here is always going to be half of your b term, no matter what's going on. If you did it correctly, this right here will always be half of your b term. Everybody okay? Everybody straight? All right, so now we have a square that's on this parentheses because I want to solve for x now, but I need access to x. So in order to get access to x, I need to remove the square from that parentheses. So I'll take the square root of both sides. So that's what I did here. The square root and square cancels. And that leaves me with x minus 3 equal to plus or minus square root of 3. So this right here is your square root property. So whenever you take the square root of both sides, you have to use plus or minus on that side that you weren't canceling out the square on. So plus or minus has to be used whenever you take the square root of both sides. All right, now to finish it off, we can add 3 to both sides. 3's cancel. And then here I have plus or minus, well, 3 plus or minus square root of 5. And that would be your answer. Problems before we do another one? Any questions? All right. So next one, 9x squared minus 6x minus 4 equal to 0. So this time, a is not equal to 1. So that means we need to divide by a. So we divide each term by 9. So the 9's cancel, leaving me with x squared. 6 over 9 is 2/3, and then 4 over 9. And of course, 0 over 9 on the right side of the equation is just 0. Everybody good? So now we need to take the 4/9 to the other side. So we add 4/9 to the both sides. So x squared minus 2/3 x equal to 4/9. All right. So now we need to take half of the b term and then square it. So we have negative 2/3. That's our b term. So we take half of that. So notice how I did that right here. Just 1/2 times that negative 2/3. So that 2 cancel. And the top and bottom leave me with just negative 1/3. And then squaring negative 1/3 is 1/9. Down here in the box, you just added 1/9 to both sides of the equation. Questions? Any questions? All right. So factoring, remember, whatever half your B term is, that's negative 1/3. That's what goes in your factorization. So you don't even have to try to factor out this. Just know that whatever half your B term was, it's going to be that, and that would work out for you. So we have x minus 1/3 squared, and then adding these together, 4/9 plus 1/9 is 5/9. All right, questions. Make sure we're all right. Square root property, take the square root of both sides. That cancels out the square here, leaving you with just x minus 1/3. And then once again, plus or minus on the other side. All right, so here right here in the blue circle, take the square root of both top and bottom. To simplify that further, square root of 5, you can't do anything with, but the square root of 9 is 3. So now I have x minus 1/3 equal to plus or minus square root of 5 over 3. Right. To finish it off, gonna add 1/3 to both sides. We have 1/3 plus or minus square root of 5 over 3, or 1 plus or minus square root of 5 over 3. Both of those are the same thing. So either way, you should get the same answer. Oh, either way, the answer should be correct. Questions? Any questions? Make sure we're okay. So that's completing the square. Any questions with the process of completing the square? All right, so once again, checking to see what A is. If A is not 1, you divide each term by A. So and simplify that. Then from there, step 2, isolate the constant. Step 3, take half of your B term and square it and add both of those to both sides of the equation. Factor. And remember, whatever half your B term, I still have my eraser on. Whatever half your B term is, that's your main part of your factorization. Simplify what's on the right side, take the square root of both sides, and then finish solving. And don't forget, always add plus or minus when you take your square root. Everybody done with that? All right. So like I mentioned, 18.2 is quadratic formula. And so we have that right here. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So notice that ABC holds to the formula when one side is set equal to 0. So you can't just pick out what A, B, and C are unless one side is set equal to 0. Something happened right here. Okay. So you always want to set one side equal to 0 when you want to use the quadratic formula. All right. So for the first one, we have 8x squared plus 2x equal to 1. First thing we need to do is set one side equal to 0. So we're gonna subtract 1 from both sides. That'll give us 8x squared plus 2x minus 1 equal to 0. Mhm. So now we know what A, B, and C are. A is 8, B is 2, C is -1. And then we can plug it into the formula accordingly. Make sure you don't lose a negative, especially when B is negative. I think that will happen in the next one, but make sure that negative in front of the B stays there. You don't lose it in your substitution and calculation. So that's -2 plus or minus the square root of 2 squared minus 4 times 8 times -1 all over 2 times 8. Now we can simplify what's under the radical. 2 squared is 4. 4 times 8, well, -4 times 8 times -1 is positive 32. 4 plus 32 is 36. Square root of 36 is 6. So now we have 2 plus or minus 6 over 16. Of course, let me know if I scroll up too far. So since I can add and subtract 2 and 6 from each other, you are expected to do so. Now, if this was 2 plus or minus square root of 6, then you could leave this the way it is. But because you cannot add or subtract 2 to the square root of 6 evenly without dealing with decimals. But you can add and subtract 2 from itself. So 2 from itself from 2, add and subtract 2 from 6. So that's why you have -2 plus 6 over 16, -2 minus 6 over 16. And so that'd be 4 over 16, which is 1/4, -8 over 16, which is -1/2. Questions? Any questions? All right, so let's do it again. (3x squared minus 2x plus 4 equal to 0) is already set equal to 0. So we can just go ahead and pick out what A, B, C are. So A is 3, B is -2, and 4 is C. And then from there, we plug it into the formula. And so here, notice we have a double negative. Make sure you don't lose a negative when you do your substitution. There's a negative in the formula, and B is -2. So it should be -2 or -2. Plus or minus -2 squared, square root of -2 squared minus 4 times 3 times 4 over 2 times 3. Any problems? Okay, simplify -2, 2. Well, -2 is +2. Plus or minus -2 squared, which is 4. Then -4 times 3 times 4 is -48. And that's all over 6. excuse me, 4 minus 48 is negative 44. So then over here in this blue box, shows you how you can break down the square root of negative 44 as simple as possible. So taking the square root of negative 44, break it up into negative 4 times 11. Take the square root of negative 4, which would be 2i, and leave the 11 under the radical. All right, so then we can simplify it further by distributing 6 to each term because they are imaginary. It's a complex number. And that'll be 1/3 plus or minus I squared root of 11 over 3.
So, Mr. Tucker, is that how far we're going to be going with the homework down to like the 1/3 plus or minus there at the very bottom? That's going to be how far we're going to be going in the homework.
Yep. Mm-hmm. Mm-hmm. Any other questions before we do? I think I got at least one more like this. Just try to cover different scenarios you'll see. All right. Can I go off the next page? Anybody copying this still? All right. So okay, yeah. So I did this one because I had a fraction involved. We have still doing quadratic formula, but we have 1/5 y squared minus y equal to negative y, excuse me, minus 1/20. So since we have fractions involved, what we could do is go ahead and clear out the fractions by multiplying both sides by the LCD. We talked about this process before, so it shouldn't be brand new to you, but if you hadn't used it in a while, you're going to find the LCD of each denominator, 5 and 20. Smallest number that both 5 and 20 can divide into evenly would be 20 because 20 can divide into itself. And you multiply each numerator by the LCD. So notice we multiply each by 20. So multiplying each by 20, that allows the denominator to cancel out into the LCD. So notice 5 goes into the 20, leaves you with 4y squared. 20 times negative y is just negative 20y. And then the 20 cancels out in that last term, it leaves you with just 1. Questions? Any questions? All right, so now we want to set one side equal to 0. You could have taken 4y squared to the other side, but I like to have my leading coefficient positive. It doesn't matter. So I just brought 20y and 1 to the left side. So I added 20y and added 1. I like to do this like this now. Hold on. So we added 20y to both sides, added 1 to both sides. That gives us this new equation of 4y squared plus 20y plus 1 equal to 0. Everybody good? So now that we're here, we have one side set equal to 0, and we're out of fractions. We completely removed our fractions. We can go ahead and pick out A, B, and C. A would be 4, that's in front of your squared term. B will be 20, that's in front of your linear term, the one that's just, y, just x or whatever. And then C is your constant, which is not connected to any variable at all. Questions? Any questions? Everybody good? All right, so let's plug in accordingly. B is 20. A is 4 and C is 1. So we have negative 20 plus or minus square root of 20 squared minus 4 times 4 times 1, all over 2 times 4. All right, simplify. We have negative 20 plus or minus square root of 400, because 20 squared is 400, minus 4 times 1, which is 16. And that gives us negative 20 plus or minus square root of 84 over 8. All right, so I broke up that 384 into 64 times 6. So once again, I want to be able to simplify that square root of 384 as much as possible. So 64 times 6 is what can help me here, because I can take the square root of 64, which is 8. So we have negative 20 plus or minus 8 square root of 6 over 8. Questions, questions, questions. Make sure we're okay. All right, so take the 8 into each term. The 8 that's in the denominator anyway. And then simplify. So it'll be negative 5 over 2 plus or minus 8. Questions, any questions? All right, questions on either one of the processes that we talked about today. So that's completing the square and the quadratic formula that we discussed today. We're good, right straight. Okay, so next class, all we have left is to knock out 18.6, which is graphing quadratic equations. And then from there, we would just be looking to review whenever you guys need it. And then I'll also, look at taking our tests. So remember, you got to get a 75 or better on each one of your tests. And you're supposed to be looking to do the same thing for your homeworks in order to, knock out the class. So after next class, really our class days would be room for you to take tests during those times. And you would come to class, just like you do on the office hour, come to class, make sure your camera is enabled. If you're going to take the test, let me know which test you're going to take, and I'll shoot you that password, and you just stay on and take it. All right. Questions? But somebody said they have a question on 17.7. But anybody have any other general questions?
Is there class this Thursday, it being a holiday? I think it's
What holiday is it?
It's Veterans Day.
Yeah,
Veterans Day? Let me make sure. I'll shoot an email out.
Okay.
I don't mind recognizing it as a holiday, but of course, do want to make sure, I'm upholding TCC's
Yeah.
stuff. We should be good even if we recognize it as a holiday, because like I said, all we have is one more section left. So let me shoot that email out, and then we go from there. Yeah. So be on the
Okay.
lookout, guys, for that. And if we do go ahead and observe that holiday, then that just means we'll pick up on Tuesday with 18-6. Mhm. All right.
Sounds good. Thank you.
Thank you. Thank you. All right. So we do have a question on the floor. If you want to sit back and wait, look to see what his question is. If it helps you out, feel free to do so. If not, have a good day, be safe, and I will see you next class.
Have a good one.
Thanks,
Have a
you
great
the
day,
same.
sir.
Thanks, you the same. All right, sir. You said you had a question 17-7. What you got?
Yeah, if I'm multiplying the radicals, like,
Okay. Is there one in particular you want to see done, or
yes, it's -15 under the radical sign.
okay? Hold on. Let me go back to that. -15 under radical. All right.
Times -7 under the radical.
Okay. So it's just like that.
Yes.
Okay. Okay. So what you would do, the first thing you would do is take the I out. So because we have these negatives under the radical, you do want to recognize that first. So that's going to be I square root of 15 times I square root of 7. Mhm. So now you can multiply them together. And I times I is I squared. 15 times 7, that's going to be 105. Mhm. Now, I squared simplifies to -1. So you should never have I squared as a part of your final answer. So it's going to be negative. And then let me see. 21. So I can't break up that 105. So that's just 105. Negative square root of 105.
So will it be like that for solving for all of the questions like this?
Yep. So you always want to, like I said, bring out that I first, because if you have a negative under the radical, I squared always simplifies to -1. Now, if I could break this down, then I would. Now, let's say if I did that, and let's say my result was negative 32, then I could break that up into 16 times 2, take the square root of 16, leave the 2 under the radical, and that's going to be -4 square root of 2. So if you can break up that number under the radical, one of the factors being able to be, and you be able to take the square root of one of the factors of that number, then you are expected to do so. Here, the only thing we had was 3 times 5 times 7. I can't take the square root of either one of those. That's why I left 105 that way. Mhm. So that makes sense. That's okay.
Yes.
Okay. All right. Did you have another one?
Thank you. That was good for me too. Have a good week.
All right. Thanks. You do the same, sir.
Thank you.
That was the only one I had a question on. Thank you.
Okay, no problem. And next class, we'll have room for questions as well. So you can bring them to next class. We'll knock them out, man.
Okay, so you said once we finish 18, we start taking tests on our class days, right?
We can do it our class time. Yep. And you don't have to schedule anything. You just come to class, say, hey, Mr. Tucker, I wanted to take tests, whatever. And I'll send you that password. We do it from there.
Okay, so for this Friday, can I go ahead and retake the last one, or can I just move on and go back to that one?
You can do whatever you like.
Okay.
Yep. Whatever you want to do. Whatever's going to be easiest for you. If something is fresh, you want to knock it out now, that's fine. Go back to the other thing later. Whatever way, works best for you. All right.